Welcome students to another lesson. In this lesson, we'll discuss power of lens. Okay, so why we need to discuss power of lens? Now, look at this two lenses. This is your lens A, this is your lens B. Fine. Suppose you have this two lens. Now, how can we differentiate between this two lens? Both are convex lens. Okay, but how can we differentiate between two lenses? Now, if you look carefully, okay, consider this incident light. This incident light falls on this lens and after refraction it passes through this point. Whereas this incident light also after refraction follows this path of light. But whereas in case of your lens B, again a parallel incident of light after refraction it passes through this point. The second incident ray after refraction passes through this point. Here, can you see the difference? This intersection point is very close to the lens, but whereas in lens A, this intersection is very far from the lens. Okay, so what is this distance? This distance at which the light intersects at the principal axis is known as your focal length. Fine. And for your lens B, this is the distance of your focal length. Okay, so one difference you can notice is that in case of your lens A, it has large focal length as compared to your lens B. Fine. Apart from this difference, can you see why there is a difference in this large and small focal length? Okay, consider this first incident light. Okay, this light was supposed to travel in this direction. Okay, let me denote it by green pen. Fine. This light was supposed to travel in this direction, but it got bent by a small amount of angle. Fine. Whereas in case of your second lens, again, the incident light was supposed to travel in this direction, but it got bent and it started moving in this direction. Fine. Now, can you see the difference? There is a difference in the angle. So, why is the difference in the angle is appearing? This is appearing because the difference of the power of the lenses. This your lens A has less power. Less power means it can bend the light less as compared to your lens B. Can you see? Since it bent the light less degree, therefore this angle is small. But whereas in this case, there is more bending. Okay, so here you have large bending. Fine. So there is a difference in the bending, and this difference is known as, or this bending difference is known as the power of lens. Your lens A has small power, so it bends a light small, whereas lens B has more power, so it bends the light more as compared to your lens A. The lens A has less power, so less bending. Okay, the lens B has more power, so more bending. Fine. So for this power of lens, I can say that the power of lens can be defined by the angle by which it converges the light. Fine. For your convex lens, it converges the light. As you can see, it has more convergence in case of your lens B as compared to that of your lens A. Can you see? Now, this is also applicable for your diverging lens. That means your convex lens. Again, compare your lens A and your lens B. In this case, the light diverges less as compared to your lens B, where the light diverges more. So I can also say that the power of lens is the measure of the degree of divergence. Fine. The more it diverges, okay, as you see in the lens B, the more it diverges means the more power. The less it diverges means the less power. Fine. Fine. So on this note, we can start power of lens. Now, in this topic, we will study what is meant by power of lens. We will define its SI unit, and we will categorize the lens which has positive power and which one has negative power. And then finally, we will express the power of lens in terms of its refractive index and the radius of curvature or your radii of curvature. Fine. Now, as we have already discussed, the power of lens is defined as the tangent of the angle by which it converges or diverges a beam of light falling at a unit distance from the optical center. Okay, so let us again consider your convex lens. Suppose this is the incident light. After diffraction, it passes through this point. Okay, now actually the incident light should have traveled in this direction. It forms this angle. Fine. So the power of lens is defined as the tangent of the angle. Can you see this is the angle? Fine. This is the angle. This is the line drawn along the angle. Okay, so this is the tangent of the angle. Fine. Or I'll say this line. Fine. This is the tangent of the angle. Okay, the one arm of the angle. This is also applicable for your concave lens. Okay, suppose this is your light. Okay, after refraction, it passes through this point. Fine. Now, can you see this angle? Fine. So this is the yellow line. Okay, consider this line. This is the tangent of the angle. Fine. The tangent of the angle by which it converges. That means it moves towards a particular point. Okay, it converges or diverges. Diverges means moving away from a point. Can you see it is moving away from this point? So the tangent of the angle by which it converges or diverges the beam of light falling at a unit distance from the optical center. Fine. That means a light which is moving at a unit distance. Fine. The power of lens is defined as the tangent of the angle by which it converges or diverges a beam of light falling at a unit distance from the optical center. Fine. Fine. Apart from this one, if the focal length is small, in that case you have large bending power. And if focal length is large, then in that case you have small bending power. Fine. So this is your power of lens. Fine. Now we will define its SI unit. Fine. So consider again your convex lens. This is your convex lens. Fine. Let me make this one a little bit big. Okay. So this is your convex lens. Consider this line as your principal axis. Fine. Now, now consider a light which falls on this lens. Fine. The light is supposed to travel in this direction. But what happens? The light after refraction from the lens passes through this point F. Fine. Let me just make this figure a little bit bigger. Fine. Now, can you see the light has bent by this angle? Let me represent this angle by delta. Fine. So, this is the degree of convergence. Fine. Now, consider this distance. Okay, the light is incident at this distance from the optical center. Let this distance be represented by h. Fine. And the light falls on the principal axis at this point, which is your f. So this length is your focal length. Fine. Okay. Now the by the property of the corresponding angles of the parallel lines, I can show that this angle and this angles are equal. Fine. These are your vertically opposite angles of your parallel lines property. Fine. So this angle is also represented by delta. Fine. So if you have represented this by delta, in that case you can write what is tangent of this angle. Tan of delta. Tan of delta will be the ratio of the opposite side. This is your opposite side. H divided by the adjacent side. This is your adjacent side. Okay. F. So tan delta equals to H by F. Fine. Now, as the power of the power of lens, from the definition of the power of lens, we can say that the power of lens is defined as the tangent of the angle by which it converges a beam of light falling at a unit distance. Can you see this line? I'll highlight this one. Falling at a unit distance from the optical center. Fine. Which means, can you see this length? This length? This length is how much? It is a unit distance. That means your h should be equals to how much? 1. This is the meaning of a unit distance. Fine. So if h equals to 1, fine, then in that case what happens to your tan delta h by f? Tan delta equals to, in place of h I can substitute 1. Okay, I'll substitute this 1. So I have 1 by f. Fine. And what is this tan of delta? Tan of delta means this line. Okay. Or from the definition you can look, the power of lens is defined as tangent of angle. See, tangent of angle by which it converges or diverges a beam of light falling at a unit distance. So the tangent of light, or the tangent of the angle by which it converges a beam of light falling at a unit distance. Fine. So this is the definition for power. Fine. This tangent is your power. So instead of tangent, I can also write, okay, let me just move this tangent little bit upwards. So power equals to 1 upon F. Fine. So this is the formula for power. Let me just put this inside a bracket. This is the formula for power. Fine. So if P equals to 1 by F, okay, now we can define its SI unit. Okay, so if P power equals to 1 upon F, fine, you know what is the SI unit for F? The SI unit for F is meter. Fine. So I'll write, if F is how much? 1 by meter. So what should be the SI unit of power? The SI unit for power SI unit of power is 1 by m, which also can be written as m to the power minus 1. Fine. This m to the power minus 1 can also be written as capital D. This D is known as diopter. Fine. Therefore, I can write the SI unit of power is the SI unit of power is diopter, which is represented by capital D. Fine. Now, if the power is D, in that case, what will be the dimensional formula? You know, one diopter is how much? 1 meter. Fine. Meter in terms of dimension, I can write m to the power 0, L to the power 1, T to the power 0. Fine. Or this can also be written as, if I take this one, if I take this to the numerator, then I can also write this one as m0 L minus 1 T0. So this is the dimensional formula for power. Fine. Or your diopter. So we have defined what is a power. Fine. We have given and defined its SI unit. What is the SI unit of power? It is diopter. Fine. And also we have given the formula for power. Power P equals to 1 by F. Fine. Finally, look at this 1 by F. Okay. Now let's go back to your lens maker formula. Okay. So look here. According to the lens maker formula, 1 by F equals to mu minus 1, 1 by R1 minus 1 by R2. Fine. So let's substitute this formula in the power of lens. Fine. So from the lens maker formula, 1 by F equals to mu minus 1, where mu is the refractive index, divided by or multiplied by 1 by R1 minus 1 by R2, which is the R1 and R2 are the radius of curvature. Fine. So I will just extend this for. So this is the formula for power of lens. Fine. So we have expressed the power in terms of the refractive index and the radius of curvature. Fine. Okay, so that's it for today's class. Thank you. And if you have any confusion, please don't hesitate to ask. I will re-explain it to you again. In our next class, we'll discuss combination of thin lens. Fine. After discussing the combination of thin lens, then we will solve some numericals based on the power and the combination of thin lens. Fine. So that's it. And again, thank you.